Welcome to Fabric Monday. Today we'll talk about the optimal refresh in Materialized Lake views. We already saw how the Materialized Lake views work and how the constraints in Materialized Lake views provide a great data quality feature. But what we were missing was the incremental refresh. The possibility to refresh only the changed information in the Materialized Lake view. This was released under the name of optimal refresh. Let's see how it works. The optimal refresh creates three options for the refresh of the Materialized Lake views. What do these options mean? This means that when we schedule the refresh and when the refresh is about to be executed, the lakehouse takes the decision about which of these options will be used. No refresh. This means that the source data will be checked and the lakehouse will discover that nothing changed. There was no change in the source. In this case, no refresh will be done. We can schedule our Materialized Lake view to refresh every 3 minutes, and still the lakehouse will see that nothing happened, so no refresh will be executed. Full refresh, when some changes on the source happen, but the view is not supporting incremental refresh, the full refresh will be executed. So the source changed, but incremental refresh is not possible. Incremental refresh, only changes are loaded into the Materialized Lake view, but the incremental refresh is very demanding. It's the most difficult one to achieve. The two first ones we can easily achieve, but the incremental refresh depends on many requirements. First, supported expressions. Incremental refresh only supports these expressions on the creation of the Materialized Lake view. If you put anything else on the Materialized Lake view, that view will only support full refresh, will not support incremental refresh. This tells a lot to us about what we can or can't do. Views using groups and summaries will not be supported for the incremental refresh. In this case, we need to carefully decide how we will use Materialized Lake views in our medallion architecture, where the incremental refresh will be supported, where it will not be supported, and where it is needed. So complex queries only support full refresh. This is a fact. Then we can enable the optimal refresh. We can visually enable the optimal refresh or manage Materialized Lake views in the lakehouse. We saw this view before, and then we enable the new button optimal refresh. Once we enable, our views will support the optimal refresh, but not necessarily the incremental refresh. To support the incremental refresh, the source data needs to have this property enabled, delta enable change data feed. This property needs to be enabled in the source. If this property is not enabled in the source, the lakehouse can't identify the changes and the incremental refresh will not be supported. Let's see how it works. Let's see an example of how the incremental refresh works. First, let's see how to check the property enable change feed in a table. I have a table called fact source. If I want to check that property, I need to use Spark SQL, and I can use describe detail and check the detail properties for this table. This is one of the methods we can use, and this table initially had no property set, but I can enable this property using the alter table set TBL properties delta enable change data feed equal true. Once I execute this alter table and ask for a describe again, then I will see in the properties field the delta enable change data feed. In this way, I can use these statements to check if the table supports this feature and enable this feature for the table. Now let's take a look on what I have in the lakehouse. I have a table fact source. This table has sales facts, many records related to sales facts. I created this table especially as a subset of the well-known fact sale table, exactly to test incremental refresh. In the same lakehouse, I created some other tables with the records for a specific product according to the product ID. In this way, I can make the inserts later in the fact source and check for the incremental refresh. Let's create the materialized lake view. Create materialized lake view fact increment, the name of my view, and I'm only selecting some fields. I could make some transformations, calculations, but I can't aggregate. Let's create this view. And that's it, the view is created. Let's analyze it in the lakehouse. Here I have the lakehouse. The view appears as a table, but it's not here yet. I need to make a refresh to actually see the view. And there it is, my view fact increment. Let's click on Manage Materialized Lake Views. Here it is, my view fact increment created from the fact source. We can see the button Optimal Refresh, and there is one interesting point. The button is enable or disable for all the views. This is still a pending point on the Materialized Lake Views. This kind of configuration, like the Optimal Refresh and the shadow for the view execution, is for all the views. It exists for all the views, not for a single view. In the psychoanalytics endpoint, let's check the history of executions of this view using the sysdq matrix. The sysdq matrix also stores the information about the refreshes of the view. I only need to look for fact increment, the name of my view, and I will execute this query. There it is. This is basically the creation of the view. The view was created at 1917 and a full refresh was executed on this view. This view had a full refresh. Of course, it is the creation of the view, and I can see the total flows which were ingested in the view. The refresh shadow is set for every 3 minutes. The view refreshes every 3 minutes. However, this information, all this information which I query in the psychoanalytics endpoint, depends on the psychoanalytics endpoint refresh. I wrote before in blog posts about the process of the psychoanalytics endpoint refresh. The psychoanalytics endpoint is a serverless feature and it needs to refresh its data. Some operations make this very visible, and one of them are the materialized lake views. So more than 3 minutes has passed and I'm not seeing the update yet. So I need actually to force a refresh on the psychoanalytics endpoint. Refresh. Let's execute the query again. And now I can see a second refresh of my materialized lake view. It's interesting how this illustrates the fact that the psychoanalytics endpoint depends on a refresh. And on my second refresh of the materialized lake view, we see that it was made at 1920s, exactly 3 minutes, no rules were processed, and it was decided to use the policy no refresh. Why? Because no change was located on the source table. No change on the source table, no refresh. Now let's force a change on the source table. I load some data from the fact56 table and I'll save this data on the fact source. But the mode needs to be append. I need to be appending this data, inserting the data in the existing table. The data is inserted. We need now to return to the psychoanalytics endpoint and check the result. Let's see. I just executed the insert of the data in the source table. I have some shadows involved in this process. First is the shadow of the materialized lake view. It's a shadow for every 3 minutes. It depends to match with the next refresh shadow of the materialized lake view. Second is the refresh of the psychoanalytics endpoint. The materialized lake view may be refreshing and I may not be seeing the information if I don't refresh the psychoanalytics endpoint. And here it is. After refreshing the psychoanalytics endpoint and executing the query again, we can see a new refresh, many new refreshes which happen in the middle of this time. And the last one, brought new rows to the materialized lake view, and not the full amount of rows, only some new rows. We can see that we achieved the incremental refresh of the materialized lake view. But I highlighted before, the incremental refresh has limitations. One of the limitations, for example, is that it can't identify changed rows. It identifies inserted rows, but not changed rows. This means that if I change rows in the source will force a full refresh. Any change of rows will force a full refresh. So in this example, I'm forcing a change of rows, making an update in the effect source. Let's see the result. I will execute this update. It's done, the data is changed. Now let's check the result on the materialized lake view. Back to the psychoanalytics endpoint. Again, we need to synchronize with the refresh of the psychoanalytics endpoint and the timing for the refresh for the materialized lake view. And here we have the result. Our materialized lake view this time executed a full refresh and got all the records from the source because the update is not supported in the incremental refresh. This is critical for the planning of a medallion architecture because one very good practice in a medallion architecture is to use slowly changing dimensions type 2. The type of the slowly changing dimensions where you keep information about which version of the record is the most current one. The SCD Type 2 involves making updates on previous records, updating, validating previous versions of the records and marking one of the records as current record. When we mix SCD Type 2 and materialized lake views, we see that we need to plan new ways to implement SCD Type 2. The default ways to implement SCD Type 2 requiring updates will force a full refresh of the materialized lake views and create a problem to us. That's good. That it is pushing us to the right direction because it's a fact that the updates in a Delta environment will create problems. These are illustrated in a very old video about Delta optimization secrets. Thank you very much for watching and see you next week.